Very good morning again, people, and welcome to the next lecture, second installment of the Simulation of Business Systems course on NPTEL MOOCs. And in the previous lecture, what we have gone through our learning agenda, the main topics was listed, and of which we covered the nature of the simulation and the brief history of simulation. And we will look into new concepts today. Mostly we will try to focus ourselves on these three: what is systems, models and the simulation, then application and the real world applications, and why simulation is needed. We will try to address these three aspects in the today's class. Okay. Probably will be a little long because we are covering quite a lot of concepts in this. So, we will try to break it appropriately so that you won't have any problem in going through the concepts. So, the first thing that we are going to look into is the concept of system, assumptions and model. Okay. This is people use these words in a very colloquial way in most of the time, but in simulation they do have very specific meaning. So, these following simplistic views, okay, the simplistic views that I am going to provide are relevant to all simulation studies. It does not matter whether you are doing computational fluid dynamics or anywhere, but these approaches, these viewpoints that we are going to study now has its applications relevant to all simulation studies. So, the first phrase that we need to know is system. Okay. People talk about system. So, what is a system? In the simulation, it is not the systems engineering system. In the simulation, what is being simulated is the system. Okay. So, the system is the stuff that is being simulated. Whatever is being simulated, or in a way the object of the simulation study. Object of what? The object of interest. Okay. Whatever you are interested in studying, that or what is being simulated, that becomes the system. Okay. That part I believe it is clear. Then we talk about assumptions and approximations. We say, oh, while building the model we have to take so many assumptions, so many approximations. These assumptions determine this, that assumptions determine this, those kind of things. So, what are they? Okay. So, assumptions and approximations are to be made to study a system, of interest. Okay. To study a system of interest, you have to make assumptions or approximations. Okay. These assumptions or approximations can be both logical and mathematical. Okay. So, some of the aspects can be logical, some of them can be mathematical, right. And why are these assumptions is to be made? Okay. They are to be made to know more about how the system works. Okay. So, an example of this is that if you are thinking about people standing in a line. So, let us say here is a shop, okay. This is a ice cream shop, okay, and people are standing in line here to buy ice creams or get into ice creams like this, and by one they will buy ice creams and they will get out. So, one of the assumptions that you can make, a logical assumption that can be make is that the lowest possible number of people is equal to 0. You cannot have negative people there. So, that is a logical assumption, okay, because it is, and you can always say that the number, the values, the number of people who are waiting to get the ice cream is always an integer value. You can't have 2.5 people. You can have an average, but realistically if you think about it, it will be the 2 people, 3 people, 4 people, 10 people, 200 people waiting in the queue depending upon how popular the ice cream area is. Okay. And then you can also write the same thing about the average waiting time to get the ice cream is 4.5 minutes, and that you can write as a mathematical expression which will become a mathematical assumption. Okay. So, these type of assumptions and approximations that we take to understand or study the system better. Okay. So, that is the main aim of taking the assumptions and approximations. So, then what is a model? All such assumptions or approximations we take to study a system forms the model of the system. Okay. Hope now you understand what is a model. These assumptions or approximations that we take to understand the system better results in the model of the system. Okay. So, your object of interest or object of interest of study is your system, or whatever is being studied is a system, and you take assumptions and approximations to better understand how the system works, and these assumptions and approximations that way translates to what we call as the model of the system. Okay. So, then many a time people talk about analytical solution. People say is that equation of a straight line. So, like for example is equation of a straight line is given by y equal to mx plus b, where m is the slope and b is the intercept, but this is a model. Okay. But when you say y equal to 2x plus 10, then that is the equation of a particular line, okay, which is 10 units intercept, and then the slope is 2. So, that means the slope is the rate of change of y over rate of change of x, delta y by delta x. So, then that means for every 2 units of rise in y, you can see that how it works out, right. So, I am not going to explain that, but this becomes a model, and this is a particular line that represents that derived from that model. But here there are certain assumptions that we assume that both x and y are in the Cartesian coordinate system, and they are also like no imaginary values, they are all real numbers, and those kind of things we assume as part of this. So, that is how this equation of line was derived, ideally speaking. Okay. So, in an analytical solution, when people talk about what is an analytical solution, if the model is quite simple, then one can use mathematical methods to obtain exact information on the questions of interest. Okay. So, if you use mathematical methods or mathematical approaches to obtain exact information on those questions that you have of interest, then that type of an approach is called as analytical solution. So, modeling a system using a mathematical equation, modeling a system using a mathematical approach, or using a mathematical method to obtain the exact information to the questions for a simple system. The important aspect is its system is simple, then you will result in analytical solving or analytical solution. Okay. So, now you know what is a system, assumptions and approach, model, and what we also call as an analytical solution. So, when do we not do analytical solution? Obviously, the answer is when the system is very complex. It is too hard to use mathematical methods to come up with the solution to the problem. Okay. So, let us study a little bit more on the systems and models and simulation. So, let us see what are the other definitions that are part of these. So, the system, the Schmidt and Taylor definition, which is very popular among many of the people, okay, then definition states goes something like this: a collection of entities. Okay. What are those entities? Entities can be parts, people, machines, methods, money, okay, like this. Okay. A collection of entities that act together towards achieving some common goal. That is what we call as the definition of Schmidt and Taylor's definition. It is a collection of entities that act together towards achieving some common goal. Such kind of a collection is, that collection of entities is what we call as a system. Okay. So, in practice, the objectives of the study determines the system. For example, you might be in a automotive factory, automotive manufacturing facility, and then you are more interested in the time taken for completing a work at each workstation. Then you might be more interested in studying the conveyor aspects of the system rather than looking into the other aspects. So, realistically, the objectives of the study, whatever you are wanting to study, that determines the system. So, you would actually be in a big factory and you would just probably focusing on the overhead cranes. You will be looking only at the material transportation system at that point. Okay. Other aspect is, in practice also, it might also limit the physical and logical boundaries of the system. So, your study objectives might also limit the physical and logical boundaries of the system. So, if you are more interested in how long it takes the crane to move overhead in the factory from one end to another, then your study objective limits only the focus to the overhead crane. It does not care about what happens, what is the electric supply, how much is the illumination in the factory, what is the rate at which the water is flowing through the taps, how much of material is being removed. You do not study those aspects because that is outside the ambit of your objective of the study. The level of detail as part of the study is a judgment call. Is a judgment call made by the researcher or analyst. So, how much detail you want to study, okay? How much detail you want to go into this study is a judgment call. The modeler or the researcher decides how much of details you want to be included. So, if you are studying about the time taken for the crane to move from one end to another carrying different weights, you are not interested in what kind of color it is being painted. What is the color of the crane? You might not be interested. You might not be interested whether the crane, the driver cabin, the operator cabin is air conditioned or not. You might not be interested too much on what is the power, horsepower of the motor that is driving the wheels of that crane. You might not be interested in any of those. So, hence the level of detail that is part of the study is the judgment call depending upon your objectives of the study. Your study objectives determine how much detail you also need to go into, and that way it also determines the physical and logical boundaries of the system. Okay. And the last part is, okay, most of the studies would like to model time. Okay. So, in a system, typical definition of the system, the definition of the system, the time is kind of left out. So, the way is dynamic behavior of the system or what we call as the time dependent behavior. Okay. How does the system behaves over time? That is one important aspect that many of the modelers would like to do. And in study of the system, even though it is a collection of entities that act together and all, but in realistically the objectives of the study limits the system, and as well as the physical and logical boundaries of the system are also determined by the objectives of the study, and the researcher and analyst, depending upon the objectives, limits the level of detail to an appropriate level, so that unwanted things are removed out. So, that is why you make the assumptions to remove unwanted things. And also one other aspect is an aspect of time, the time dependent behavior, the dynamic behavior of the system also need to be added into the study, because many of the researchers would like to know how the system would behave. Okay. Then we talk about another thing is called as a system state. Okay. So, what is a system state? So, by definition, okay, system state is a collection of variables along with their values that is necessary to describe the state of the system at a particular time instant. At a particular time instant. Okay. At a particular time, given time instant, you would like to know the state of the system. Okay. So, it is a collection of variables, a particular variables along with their values that is necessary to describe the state of the system at a particular instant. So, if you think about the ice cream example that we talked earlier, if I say that number of people waiting, okay, number of people waiting is equal to 5, okay, number of people served or being served equals 1, okay, and average time to serve ice cream is 3 minutes. If I say something like this, these variables put together, okay, and if I say this happened at, this is what is the status at t is equal to 20 minutes. So, after 20 minutes this is the state of the system. Then, so this state of the system that we just described now gives us a snapshot of the system, how the system is at a particular time, which is at the 20th minute of the system. So, this kind of the system state, it always depends upon desired objectives of the simulation study okay, and also the system output performance measures. Okay. So, at this point, what is the desired objective of the simulation study? Let us say if the desired objective in this particular case is find out that how many people were served, then you do not get an answer here. So, if I add is the number of people completed, number of people who left with ice cream is 9, if I say that. So, then that means at the time t equal to 20 minutes, 9 people have already bought the ice cream, 1 is being served, 5 are waiting in the queue, and average time of service is 3 minutes. Okay. Whether these numbers are right, it makes sense or so, that we will talk about it later, but approximately this is what the idea is about. Okay. So, this aspect that we just added here, this is more of a performance measures, system performance measures, how many people you have already sold the ice cream, because if you do not sell your ice cream, then you would not really get money. If you do not get money, then your system will not work. So, this is more of an output parameter, and whereas this is more about the system state parameter. Okay. And this is more of a output or a performance measure. Okay. I hope you guys understand this much concept in a way, and what we will do is we will continue now to extend these concepts, but be sure that you guys, when somebody says what is a system, when somebody says what is a system state, when somebody says what is a model, when somebody says what is an assumption, when somebody says what is an analytical solution, you should be able to be very clear in your mind about the concepts that we just discussed now, so that you can understand what that person is talking about. Okay. This language of simulation is new to you, and hence it is very important that you guys understand this language. So, we have been seeing the basic definitions of system, system state, assumptions and other aspects, and we also talked about why it is important to understand the state values of the state variables to describe a system. So, now let us get into the next concept, which is related to this, is called as the complexity or system complexity. Okay. Some people also call this as the complexity of the system. We call this as system complexity. Okay. So, the general rule of thumb is this: complex systems require models that are also complex. Okay. So, complex system models are usually complex. Why? The most important question is why. Okay. This answer to this is because such models have to be valid. Okay. So, to ensure the validity of the model, you have to build complex models in this regard. So, hence complex systems will require complex models. So, then therefore, simple analytical approaches fail. Okay. You cannot use those simple analytical approaches. So, hence you have to study these things using simulation. Okay. So, what you do? What do you do then? Okay. Answer is evaluate model numerically. The most important word is this: numerically. Numerical evaluation, not analytically, numerically, and collect data to estimate model characteristics. Okay. So, what we are talking here is instead of the analytical approach. So, this is the instead of analytical approach. Okay. Instead of analytical approach, what you do is you model numerically, you study the model numerically, evaluate it numerically, then you collect data, and then from that you estimate the characteristics of the model. Okay. So, a simple example of that is if you think about the ice cream. So, let us say think about you have a data collection where is called at the customer ID like this, and then time in and time out. Let us say you have collect data like that. So, customer ID 1, 2, 3, 4 like this, the customer ID is going on, and the first person comes in at 0, 0 and leaves at 120. The other person comes in at 2:30 and leaves at 3:45, and this person comes at 3 and leaves at 5:15, and this person comes at 7 and leaves at 10 or something like this. So, when you numerically study this, so this is where you are simulated the arrival of people into the ice cream shop, individual people come into the system. So, the first person came in when the ice cream shop opened and stayed in the shop for 1 minute 30 seconds. So, the time spent you can calculate here will be 1 minute 20 seconds. This person came in at 2:30 and left at 3:45. So, this person spent close to 1 minute 15 seconds on this place. This person spent 2 minutes 15 seconds. This person spent 3 minutes on the shop, something like this. So, then using this you can find the average of this. If you sum this and divide by 4, then you will be able to get what is the average time spent in the shop and stuff like this. So, this type of an analysis is what we call as a numerical analysis, okay, instead of a mathematical model. So, let us think about a simple example. An automotive manufacturing company, okay, a car manufacturing company is considering to extend its plant. Okay. So, the one option is build the factory, build the extension to the plant and evaluate whether it will work out. Okay. This is one approach, but let us say you build the factory, you build it and then you evaluate whether it works out. If it does not work out, then demolish and build something else. And this process continues. So, what is the major issue with this approach? The problem is it is very expensive approach and quite wasteful. Okay. You keep on building and destroying, that is what you are trying to do in this case. So, instead the other option, better option, what is the better option is to simulate the current system, and then expand the model, okay. Use the new model to evaluate performance and then choose. Accordingly. Okay. So, the simulation approach would be simulate the current system. So, build a model, okay, of the current system and then expand the model to include whatever is the extension of the plant. So, this expansion and this extension mirrors one another and then use this model to evaluate the performance and decide whether you should do this extension or not. Okay. So, this is one other approach of how do you deal with the complex systems. So, simulation, so another way to do it is simulation provides better ways to handle complexity. Okay. So, you can study complexity in a better way using simulation. You can model complex systems using simulation better. Okay. All right. So, now let us look into the next concept, which is the applications of simulation. Okay. And what we are going to do is we are also going to look at the, I will just add the phaser here saying that major applications of simulations. We are only going to study some major applications, not all applications. Do not think that these are the only areas to which simulation is applicable. These are some of the majority of the areas. So, the first one is the manufacturing systems. In manufacturing systems, the main aspects where simulation is involved is design of manufacturing systems, analysis of manufacturing systems like analyzing the takt time or what you call a cycle time, the throughput rate, work in process inventory, etc. Then inventory, how much of stock is there, okay. Automation, that is another aspect you study. Layout, okay. Material handling, etc. So, these aspects of manufacturing systems, the design, the analysis, inventory, automation, layout, material handling, etc., are all studied as part of the simulation. Similarly, in military, simulation also finds a lot of application. As I mentioned to you guys, simulation actually came from military only, Monte Carlo simulation. So, in this case, what we are major studying is weapon systems, then logistics, okay, military logistics. This is includes troop movements, etc. Okay. Then tactics. Tactics is short term, long term. Okay. Then what we call as bomb damage assessment. Okay. It is popularly known as BDA, okay, bomb damage assessment. Then training, providing training to the troops. These are all aspects that you can use simulation to. So, the training, a very important thing is you might have studied something called as flight simulators and all, okay, flight simulators, etc. Okay. It teaches a pilot how to fly a new aircraft. So, because if you give them a new aircraft to fly and then they crash it, then the cost will be very extensive or extraordinary. So, instead you make a simulation model of it and train the pilot to fly the simulation model, so that when the pilot actually gets into the real aircraft, then the chances of error are very minimal. Okay. Similarly, in computer systems, we can talk about modeling of hardware components. Okay. What would be an optimal hardware components? Okay. Hardware components. Then software systems. When you design a particular software system, how will it actually behave? What is the speed of it? Then modeling and analysis of networks, okay, the traffic, congestions, that aspects of it. Database management systems, or what popularly known as DBMS, okay, etc. All right. These are all aspects of computer systems. Then designing an operation of transportation systems. This includes airports, okay, then also includes highways or freeways, then shipping ports, okay. It also includes subways, or what is popularly known as metros, and so on, okay, etc. So, like for example, in an airport, you want to study, like for example, in a big airport like in Delhi, simulation is heavily used to determine which gate should be assigned to which aircraft. And you can see sometimes the aircraft will get delayed, then the entire gate assignment will go for a toss, and immediately simulation can provide you a alternate solution quickly, so that you can minimize the taxiing time of the aircraft from the runway to the gate, and also as well as the travel time from the gate to the runway, so that quick takeoff and quick landing and the quick movement of the aircraft, the time to which an aircraft that remains in an airport can be minimized, because the job of the aircraft is to fly, not to stay in an airport. So, that can be taken care of by, so that is a performance measure that can be built in, and you can use simulation to study the to make the operations of the airport better. Similarly, evaluating the design for service organizations like hospitals, okay, deciding where to put the operation theaters and stuff like that, call centers, okay, how many people are necessary for call centers, how to do things like that. Then you can study about fast food restaurants, okay. McDonald's is an example where they depend heavily on simulation to study how many counters are to be opened, etc. like that. Post office, okay, then border control, etc. Control on another common term of this is called customs, etc. Okay. All right. So, these are the aspects of how do we do service organizations. Then business process re-engineering, this is like looking into individual business processes, and then suggest improvements or re-engineer. Okay. Re-engineer. So, these studies, when you model these business processes can be complex business processes can be easily modeled with the help of simulation, and then study the possible improvements, and you can quantify those improvements before actually implementing the changes to the actual process. Okay. Similarly, the last part is the analyzing the financial. This is not the last part, some of the major applications in which financial and economical systems. So, you can study stock market using simulation. There is very popular tools available now. Then commodities includes gold, iron, silver, petrol, those kind of things. Various pricing policies. Okay. Then also you can think about studying is the public distribution systems, okay, which we call popularly in India as ration shops, okay, the PDS. Those kind of systems can be very well studied and improved with the help of simulation, which will so by doing that we will be able to come up with a better approach or better performance measure that would satisfy the objective of the system. Okay. All right. So, now let us talk about the popularity of the simulation. Okay. How popular. So, the question we are going to ask is how popular is simulation? Is simulation now? Okay. So, the answer to this question is simulation is one of the answer is very simple. It is one of the most widely used techniques in operations, research and management science. So, in the OR field, this is one of the most widely used technique. The main reason is it is no longer a last resort. Contrary to the earlier belief that people had that when everything fails, approach simulation, now it is no longer a last resort. It is actually, it is in fact the only resort in complex system studies. Complex system studies. Okay. Now, also just to give you some statistics, simulation consistently ranks in the top 3 most important techniques in business. So, you can see that it is one among the top 3 most important techniques almost all the time, because people are being dependent on it quite heavily for doing better things. So, what does simulation allows us to do? Why is this technique so popular? Because simulation allows us to model. Model means it allows us to model complex systems in a very detailed way. Okay. It allows us to model the complex system in a very detailed way. It also allows us to describe the system. Okay. Describe what? Describe the behavior, okay, including time dependent behavior. Time dependent behavior. Okay. Describe the behavior of the system. That is one other aspect. Then is the construct. Okay. It allows us to construct what? Construct hypotheses, thesis or theories. Okay. Hypotheses, okay, about the observed behavior of the system. Okay. So, it allows us to frame intuitions. Why is it like this? Okay. Why is it actually do? Why is the system doing this? It allows us to come up with an explanation on the exhibited behavior of the system. It also allows us to use what? Use the systems model to predict future behavior of the system. Allows us to predict the future behavior of the system, which implies, okay, the effects that will be produced by implementing changes in the system. So, if you build a for example, if you build a model of a car manufacturer and you say, okay, fine, as of now I am using the factory and I am producing 200 cars in a day. What would happen if I increase the car production to 250 cars a day? Well, you can say that, oh, well, that's okay, you will just start to come up with additional raw materials and some more money and some more capabilities. Might not be true. You might, when you do the simulation, you will find out that, oh, well, the current fire suppression system that is created, the safety system that is created is not sufficient or not capable of handling any issues that happen due to the production of 250 cars. So, it is not just straightforward. We will have to now come up with a new mechanism, and a classic example of this is the Brandenburg airport in the Berlin, where you can know that when the airport is now being built and when it is completed, they are in a situation where the fire suppression system is found completely inadequate. So, they have to now come up with a option of redoing the entire fire system or demolish the terminal building and build the entire thing new, which might be cheaper at the end of the day. So, such kind of really drastic or failure systems can be avoided, because if you build a model and use it and study what will happen in future when something gets changed in the system, and when you have a reasonably good believable answer, that gives you the confidence to go forward and implement the change accordingly. And finally, it also allows us to analyze. It allows us to analyze proposed or modified systems. Okay. So, simulation allows us to model the system, model complex systems in a very detailed fashion, so that you can study the system. Why do you model the system? So that you can study. You can study properly. Okay. You do not want to experiment with the real system, you want to experiment with a model. You can describe the behavior of the system, time dependent, including the time dependent behavior of the system. You can construct various hypotheses or intuitions about the observed behavior of the system. Why is the system doing what it is being doing now? And you can use these systems model that you have developed to predict the future behavior of the system, or the effects that will be produced in the system due to some proposed change in the system. And once you can quantify that, then you can go ahead and decide whether to implement the change or not. And also it allows you to analyze the proposed or modified systems, and once you analyze and you can come up with a rational suggestion whether this proposed change or the modified system is better or worse. So, now we will get into the next concept, which is called as the advantages of the simulation. And the biggest thing that we should understand is the simulation's greatest strength, why it is one of the top 3 most popular tool, is its ability to answer the what if questions. Okay? What if we increase the production from, what will happen if we increase the production from 200 cars to 250 cars? What happen if we change the fire suppression mechanism from the existing one to something else? What happen if we change the current lathe machine, which is running at 200 parts an hour, to a lathe which can make 400 parts per hour? Will it bring profit? Will it improve productivity? That kind of things. So, these what if questions, because if the minute you can answer this, that is what is called as alternate analysis. Okay? Ability to analyze alternatives. Okay. So, these 4 points are kind of important. The following 4 points are important to you guys, because once you understand this, then it will help you in realizing why do we need to do simulation studies. So, the first part, it is the study the existing system. Okay. Study the given existing system without disrupting. This is the biggest advantage of simulation, without disrupting ongoing operations. Or what you are trying to do is, you can study the existing system, the existing product system will continue to do the production, and then we can go from there. Okay. And the second part is, the second major aspect is, you can test the proposed system, before committing the resources. So, before committing money, before committing people, before committing materials, you can actually test the proposed system. Okay. The third aspect of the simulation is allow the control of time, or study the time dependent behavior. This is, I said earlier also this. Okay. Time dependent behavior of the system. So, you can study how the system will behave as time progresses. And then the last part is, provide insight to those system variables. System variables are, they describe the state of the system that are most important to the system performance. Okay. So, these 4 aspects are the advantages of simulation that are so unique to simulation, other than compared to all other studies that are available. Okay. So, we will get into the last slide, and we will kind of conclude today's lecture here. Well, obviously, any system that has an advantage, it will also have a disadvantage. Okay. So, the simulation is also not without its disadvantages, and there are some disadvantages, and let us take a look into it. Building of a model or a systems model is an art and a science. That people make this statement. What does it means? It implies that quality of the analysis using the model is dependent upon the quality of the model. Okay. All right. So, which implies quality of the model is dependent upon the skill of the modeler. Okay. So, the success of the simulation study, okay, or success of building the model is dependent on the skill of the modeler. Skill of the modeler is something. So, better skill the modeler is, better the model will be. So, that is an issue. So, the modeler plays a very important part in the simulation study. Okay. So, the study is dependent on the skill of the modeler. Sometimes the results are hard to interpret. A reason being is, when a complex system is studied, there are many performance measures. Okay. Targeting one might worsen the other. So, an example of this is if you say that I want to minimize the scenario where the machine and the worker should not be idle. So, I want as much as work pieces right next to them so that they can continue to work. Well, that would ensure that the worker and the machine keeps on working or they are utilized heavily, but then it will also create a disadvantage that the work in process inventory on the shop floor will increase. Also, the third factor is that because you are continuously overworking the worker and the machine, if anything fails, then your system will come to a standstill. So, putting the focus on one particular aspect of a complex system sometimes deteriorates someplace else. So, especially when you are studying very complex large systems, it is very hard to have a holistic view in identifying what is the best thing to do. Okay. So, that is one of the reasons why sometimes simulation results becomes quite hard for an individual to interpret, and sometimes you require a panel of experts to interpret the results. Okay. Simulation analysis can be sometimes time consuming and expensive. Okay. So, another way is that should not be used, this is a simple rule, should not be used when an analytical method can provide quicker results. So, if you can build a simple model, an analytical model, okay, or a mathematical model, and that can provide quicker results, then please go ahead and build the analytical model and use it to get quick results. Do not get into the simulation because it can be time consuming and it can be expensive. That is still, simulation is a time consuming and expensive process. It is compared to the analytical method, it is way too time consuming and expensive. So, you should not use it when the models are simple. Okay. And there is also an impression that simulation is just programming. Okay. That a lot of people think about it that way. So, the trick here is, the aspect is, there is a need for careful design and analysis of simulation models. There is a careful need for design and analysis of simulation models, or what we call as the simulation methodology. So, okay, this is not simply programming. Okay. So, you need to carefully design and analysis the simulation models, not just do the program and then call it good. That never works. Okay. And there is a lot more art in modeling than programming, than just programming. Okay. So, you have to decide what all things to be kept, what all things to be removed. That kind of aspects are also an important aspect of the development of the simulation model. That is why I earlier said the skill of the modeler is one of the most important aspects, and it is also a good thing in the simulation, and it is also a big disadvantage, because if you have a low skilled modeler, then the model that come out might not be of the sufficient detail and accuracy. So, if you have a bad model, then you get a bad result. So, garbage in garbage out is really applicable for simulation analysis as well. So, I hope now with this overview you guys would have a clear picture of why simulation is an important tool and why simulation is an important one of the three top important tools for people in the operation research and management field for managing complex systems, studying complex systems, identifying ways to improve complex systems, even study the system even before it is implemented, provide training to people to operate the system better. All these aspects, which are very valuable aspects, can be provided by the simulation. And also, as I said earlier, it is an expensive and as well as a process which is dependent upon the skill of the modeler. So, any good system will also have its disadvantages, and once you can cover up for the disadvantages by becoming a very skilled and capable modeler, then building a complex system will not be a tough thing to do. So, from the next lecture onwards, we will focus on how to build models, what are the major aspects we need to consider. We will try to learn what is Monte Carlo simulation, and then we will go from there. Thank you for your patient learning, and continue to read the assigned readings and textbooks for more information. Thank you.